Okay, good day. This is Dual Enrollment Pre-Calculus. I am Mr. McCulley, and this is lesson number 22, Inverse Trig Functions. Let's get to it. So today we're going to define and evaluate inverse trig functions. We're going to evaluate the composition of trig functions, and we are going to solve some problems using inverse trig functions. Now, what are inverse trig functions? Well, so far we've dealt with a lot of different operations in your mathematical past, like multiplication, addition, subtraction, division, square, square root. All of these things have inverses. The inverse of addition is subtraction. The inverse of square is square root. The inverse of multiplication is division. We have these new functions called trig functions, and they are operations unto their own. And so what we want to be able to have is a way to inverse that operation. And so what are those things, and what they do is this. First, the inverse trig functions are arcsine, arccosine, and arctangent. They are denoted by this information, or this notation here, sine, what looks like to the -1 power of x, and we're just going to call it sine inverse x, and that's how we're going to say that. So on a standardized test like the ACT, either one of these two notations means the same thing. Now, when you do a regular trig function, you are given an angle measure, and it gives back to you the ratio of two sides. So if I say, what is the arcsine of 30, or excuse me, what is the sine of 30 degrees, it will give me a ratio of the opposite side to the hypotenuse. What an inverse trig function does is the opposite of that. We're going to take a ratio of an opposite side to a hypotenuse, and the inverse sign or the arc sign will spit out the angle between those two sides, or for those two sides. It's not between, it's because it's sine. All right, so we need to review a little bit about trig functions, or inverse functions. So let's draw just a simple parabola. I know it's not a sine function, but we've dealt with parabolas before, and we dealt with inverses in the context of parabolas. Now, a parabola, y equals x squared plus or minus something, is certainly a function because it passes a vertical line test. There isn't any place where you could pick an x and you'll get more than one y value. But a parabola is not one-to-one, so it won't have an inverse as it is written. Clearly, for any one y value, there are two x values, and therefore, as it is drawn, this function does not have an inverse. But what we can do is limit the domain and say, let me put it back where I really wanted it, right about there, and say that this trig function has x values only greater than or equal to 0. If we are I didn't want to do that, sorry. X values greater than or equal to 2, and that makes it more for this graph, then we are only graphing those values. And this new function, this x squared, where x is greater than 2, passes both the vertical or horizontal line test and the vertical line test, and therefore it is one-to-one. Now, when we look at the trig functions, they are functions in the fact that they would pass a vertical line test, but they are not one-to-one. And since they are not one-to-one, they certainly wouldn't pass that vertical line test, meaning that for any given y value, there's more than one x value. And in this case, there's actually an infinite number of x values for any one given y value. So what are we going to do? Well, we are going to limit the domain. And so for sine x, we're going to limit the domain from -pi/2 to +pi/2. And once we do that, now we can take the inverse of that because, and you'll see here, if I go, this is the sine function, just real quick, this is a sine function, and I set up the window so it went from -2 pi to +2 pi, and from -2 to +2 on the y-axis. So the sine of 0 is 0, the sine of pi/2 is 1, and the sine of pi is 0 as well. So if I limit the domain from negative pi over 2 to positive pi over 2, all of these values that start here and go back are gone, and all of these values that are here and go forward are gone, and we're left with just all of these values right in here. Now that's important because even though it doesn't include all of the values, it includes all of the possible outputs. Any other output would be a repeat output. So by picking from negative pi over 2 to positive pi over 2, we're doing something smart. Now, tangent also has that same same set of values. Cosine goes from 0 to pi, and the reason for that is fairly straightforward. If I change this to cosine x, please let me do it like that. Okay, good. If I went from negative pi over 2 to positive pi over 2, clearly this function is still not 1-to-1. So when they go from 0 to pi, now we have all of the possible outputs as well. So we have the smallest interval where all of the possible outputs are also valid. Now, what do the graphs of those things look like? Well, I have some diagrams of them, and I do have it in the notes, and I want to show you a couple things about them. But there's better pictures in the book, so you might want to take a check at that. So if I talk about sine of x from negative pi over 2 to positive pi over 2, I kind of drew in the sine. We can kind of ignore the red part because we're only dealing with this. Now remember, an inverse is flipping the x and y values. So the point pi over 2 comma 1 in the inverse function would become 1 pi over 2, and the point negative pi over 2 negative 1 becomes negative 1 positive pi over 2. The x and y switch. And again, if you were to just grab your graphing calculator, go to your y equals, just go to my y equals there, and go second arc cosine x and hit graph, we clearly see the same value. And the reason that it doesn't go all the way down here to 0 to 1 is because it ends up being almost horizontal, and it can't reach that extra point on the graph. If we did arc sine, we might get a better result. So second arc sine and hit graph. There we go. And since this went from this is pi over 2. Pi over 2 is a little bit bigger than 1, so right there is the 1, and that's a little bit bigger than 1, so there's your pi over 2. So it does switch. Cosine, same way. 0, 1 becomes 1, 0. Pi, negative 1 becomes negative 1 pi. Tangent also switches across the line y equals x. So the composition of any function and its inverse is always going to be equal to x. So if you go f inverse of, or f of f inverse of x, you'll get x. And if you take f inverse of f of x, you should get x. This also holds true for trigonometric functions as well. And so if I say just real quick, I don't know why I have this here. Let's erase that. If I say find the arc sine of, I don't want that, of the sine of theta, the sine and the arc sine cancel out and give me just theta. And we'll use that in future lessons as our way of getting theta by itself. Alright, so as always, we're using the unit circle, and I'm hoping by now you have the unit circle memorized, but I do want to use it so that we can figure out our arc sine and arc tangent of these values. So arc sine says what angle, the arc sine of a half says what angle measure on the unit circle gives me a y value of 1/2. Okay, well I see 2. And so let me grab a highlighter. Right here I see 1, and right here I see 1. Okay, so normally we would say that the answer is pi over 6 and 5 pi over 6. But here is the problem. We had to limit the domain so that it was from negative pi over 2 to positive pi over 2. So arc sine is never going to give you an angle measure that's bigger than pi over 2. So for all intents and purposes, we can look at this problem and cancel this one out. Let's use black. We can cross that one out because all we want is this one. It's going to be pi over 6. Now, arctangent, square root of 3 over 3. Well, square root of 3 over 3 is not on the unit circle. But remember, arctangent is the ratio of sine over cosine. So it's probably going to be one that has the square root of 3 over 2. So it's either going to be pi over 6 or pi over 3. We just have to decide which order it goes. So if I look at this particular order, let's talk about this one. If I say we're talking about, and again, this is possibly pi over 3. Well, the ratio of the opposite side, or the y to the x, would be square root of 3 over 2 all over a half. Now when you do that, we can take, we're dividing fractions, so we can take the reciprocal of the denominator and multiply by the numerator. So square root of 3 over 2 times 2 over 1, everything cancels, we get square root of 3. That's not what we want. So if I go pi over 6, that'll be a half over square root of 3 over 2. Doing the same thing, we'll have a half times 2 over the square root of 3, which would be 1 over square root of 3. Get rid of the radical in the denominator by multiplying by funky 1. We get square root of 3 over 3. And again, this is the value that we want, so we're going to say it's pi over 6. Now there is another value where you would get that ratio of square root of 3 over 3, and that would be at negative square root of 3 over 2 and negative 1/2 at 7 pi over 6. But again, for arctangent, the only values are going to be from negative pi over 2 to positive pi over 2, and it's not going to give you any values other than that. So that's how you solve inverse trig functions for values on the unit circle. If you're going to solve them using calculator, I'm going to draw this, but we're going to go right into our calculator eventually. So essentially it says solve the following equation for theta. We're trying to figure out what this is. So we know just a couple things. We know that the tangent of theta can either be in the first quadrant or the second quadrant because of the domain limitation. And since both values are positive, it has to be in the first quadrant. So we could, opposite over adjacent, a little bit wider than taller. We could say that this angle theta is equal to an adjacent side of 4 with an opposite side of 3. And we could say that it's a 3, 4, 5 right triangle, but that doesn't really help us. So since this value is clearly not on the unit circle, the only way that we can do it is to find or use a calculator. So the way we're going to do this is we're going to say that the tangent of theta is equal to 3 pi over 4. Now, most of the times you're not going to do this intermediate step because it's fairly simple and you'll get it and skip over it. But we do want to say this is what we're actually doing. We are actually taking the arctangent of both sides. And so we get arctangent of the tangent of theta equaling to the arctangent of 3 over 4. Now, composition of inverses cancel. So the arctangent of tangent gives you just theta. And then this thing you can plug into your graphing calculator. Now, we're going to leave it in radian mode and just label it as radians. So the arctangent of an opposite side of, and I've already forgot, 3 over 4 gives you an angle measure of 0.644 radians. And we're done. Now, that's just the introduction to inverse trigonometric functions. That's all I've got for today. We'll do some more examples in class, ask questions. But the super Star Wars fun fact of the day: in the original release of Star Wars A New Hope, there was no episode number nor a subtitle because, not the Fox, the distributor, I guess we could say the Fox distributor, thought it would be confusing for an audience to look for non-existent previous episodes. It was added after The Empire Strike when it was re-released on April 10th, 1981. Once again, that's all I have. You guys have a great day. Goodbye.